Welcome back to Saxon Math. This is lesson 47, circumference and pi. Not the kind that you eat, but 3.14 and many to infinity more digits than that. It's a new concept. Lakeisha measured the diameter of her bicycle wheel with a yardstick and found that the diameter was 2 feet. She wondered whether she could find the circumference of the tire with only this information. In other words, she wondered how many diameters equal the circumference. In the following activity, we will estimate and measure to find the number of diameters in a circumference. First of all, maybe you don't have a clue what a diameter is. Well, a diameter is from this point on a circle straight through the center to the other point of the circle. That is the diameter. What is the circumference? Well, the circumference is from any point on the circle, let's say right here at this point, and all the way around this circle. This is considered the circumference. Now we all know this is just a silly math book. Lakeisha probably was never wondering how many diameters would be equal to the circumference. That's just plain silly. But here we can look at this circle here. If you have a piece of string and you take one of the diameter lengths of that string, so let's say you've got this particular diameter going straight through this. If I was to lay that out, and let's say we're going to start right here, I'm going to lay that diameter out. I would have one here. Here'd be one of them. That's one diameter length. Here's a second diameter length. If I was to lay a second time down, maybe I was to mark the spot on the circle, and then I mark it again. Here's another one. So that's 2 full diameter lengths. How many more diameter lengths would it require to get around or create the circumference? Well, this diameter length would stop right about here somewhere, and all you'd have left is this little area inside here. You'd have this space remaining. So here you have 1, 2, 3 whole diameters, and then this final little piece right here is actually considered 1/7 of another diameter. It's not a full diameter. See, here is one full diameter, another full diameter, and another full diameter. Well, this piece right here, this length, would be 1/7 of a full diameter. And what does that work out to? Well, it's 3 1/1400, or 3.14 is what we're most commonly referring to as pi. So when you think about pi, it's 3.14. If we know the radius or diameter of a circle, we can calculate the approximate circumference of the circle. In the previous activity, we found that for any given circle, there are a little more than 3 diameters in the circumference. Some people use 3 as a very rough approximation of the number of diameters in a circumference. The actual number of diameters in a circumference is closer to 3 1/7, which is approximately 3 1/1400. The exact number of diameters in a circumference cannot be expressed as a fraction or as a decimal number, so mathematicians use the Greek letter pi to stand for this number. So to find the circumference of a circle, we multiply the diameter of this circle by pi. This relationship is shown in the formula below, where C stands for circumference and D stands for the diameter. So the circumference equals pi times diameter. Since the diameter is equal to 2 radii, or 2r, we can replace this D for diameter with 2r. We usually arrange the factors this way. So circumference equals 2 pi r. So this also is the same. Circumference can equal 1 diameter, or it can equal 2 radii multiplied by pi. Unless otherwise noted, we will always use 3.14 as the approximation for pi. we may use a wavy equal sign to indicate that the two numbers are approximately equal, as shown below. So pi is approximately 3.14. If we were to look up pi, it goes on to infinity, and it's never repeating, and some people know how to recite pi to hundreds and hundreds of places but from memory. But for our purposes, we'll just use 3.14 pi. It's an approximation, so it's not exactly equal. A wavy line means it's close. So to use the formula such as circumference equals pi times diameter, we substitute the measures or numbers we are given in place of the variable in the formula. So for practice set A, let's look at this one. So in this lesson, two formulas for the circumference of the circle are shown. You have circumference equals pi times diameter, and circumference also equals 2 pi r. Why are these two formulas equivalent? So they're both equivalent because, and let me just share this with you. I'll share part of this with you, I guess. You have to recognize that radius, there's two radius. If you don't know what a radius is, that would be like halfway through a circle. So if you have a circle and then you have the other half, this is one radius and this is the other radius. Well, you have two radii that make up the diameter. There's your answer. See if you can type that out and get it correct. You should be able to because I just gave it to you. Letter B. Find the circumference of each of these circles. So 3.14 times pi would be, in this case, 3.14 times the diameter. So in this case, you'd want to have circumference equals pi times diameter. And in this case, you'd plug in the values. For letter B, circumference equals 3.14 times, in this case, 2 inches. All right, go ahead and figure out the letter B. All right, so if I'm going to take 3.14 and I'm going to multiply it by 2, I would know that that would be, let me just put the 2 down here. This would be 8, this would be 2, this would be 6, and move the decimal point that far over. So the circumference would equal 6 and 28 inches for letter B. Letter C. So here's the pi, or circumference equals 2 times pi times r. So go ahead and plug in your values for those and answer letter C. So for letter C, I would take 2 times 3.14, and then I'd multiply that times 3 centimeters. So if I was to multiply the 2 and the 3 first, if I want, I can add that, and I'd end up with 6 times 3.14, or I could take 2 times 3.14 times 3. I have to multiply all 3 of these values, these numbers. So I'm going to do that here. I'm going to just take 3 and 14/100 times 6, because I know what 2 times 3 is, and that's 24. Carry the 2. That'd be 8 here. This would be 18. 2 decimal places, because there's 1, there's 2. Decimal goes right there. That means the circumference equals 18 and 84/100, and it's centimeters. That's the distance around this circle. So if we were to say, let's just say we start here, and if we moved around this distance, the circumference of this circle is 18 and 84/100 centimeters. Letter D, the diameter of a penny is about 3/4 of an inch, or 75/100 of an inch. Find the circumference of a penny and round your answer to 2 decimal places and explain why your answer is reasonable. All right, for letter D, you should have gotten approximately, and let me use a different color here. So for letter D, you should have gotten 2 and 36 hundredths inches. And if the diameter is, if it happened to be 1 inch, if we rounded this 75 hundredths to 1 inch, then you would take the circumference times that that pi times 1 diameter. 3/4 of an inch is almost 1 inch. So if we were to round that 1 inch, it'd be times 3.14. So since the diameter is a little less than 1 inch, the circumference should be a little less than 3.14 inches. So, and the exact answer actually in this case, so 75 hundredths times 3.14. Let me just show you using a calculator. So if I have 75 hundredths, that looks like this, times 3.14, you'd end up with 2 and 36 hundredths inches if you're rounding it to the nearest hundredth place. Round your answer to 2 decimal places. So that would be in that position right there. So that's exactly what the answer would be, rounded to the nearest 2 places. This is not an estimation, I guess, really. I don't know why they did that, because they ended up, the book gave us 2 and 36 hundredths inches. If we're thinking about it being as 1, it'd actually be closer, it'd be 3.14 exactly, but the book gave us an exact answer there. Letter E. Roll a penny through 1 rotation on a piece of paper. Mark the start and the end of the roll. How far did the penny roll in 1 direction? So again, referring to a penny being 3/4 of an inch for the diameter, you should be able to understand how far that penny would roll if you were to roll it on the surface. So for letter E, because the diameter is, the circumference is going to be that 2 and 36 hundredths inches, you're also going to roll the penny approximately 2 and 36 hundredths inches for letter E. 2 and 36 hundredths inches. And in the textbook in this case, they said that it would actually be 2 and 3/8, and 3 divided by 8, you'll see is 375 thousandths inches. So 375 thousandths would be pretty close. The distance to the nearest inch, I guess, nearest eighth of an inch would be 2 and 3/8 inches. All right, and letter F. The radius of the great wheel was 14 and 77/8 feet. Which of these numbers is the best rough estimate of the wheel's circumference? Would it be A, 15 feet, B, 60 feet, C, 90 feet, or D, 120 feet? Your best answer would have been C, 90 feet. The radius is about 15 feet. So you'd have to multiply 15 times 2. And then when you do that, 15 times 2 is 30. Multiplying that times 3, 30 times 3.14 would be approximately 90 feet. 30 times 3.14 would be closest to 90 feet. Letter G, use the formula circumference equals 2 pi r to find the circumference of a circle with a radius of 5 inches. All right, for letter G, so I'm going to plug in the values. I'm going to start with circumference equals 2 pi r, and then I'm going to plug in 2 times 3.14, and the radius is 5 inches. I know what 5 times 2 is 10, and if I take 10 times 3 and 14 hundredths, I know that I need to move the decimal 1 place to the right. So I know that the circumference is going to be 31 and 4/10 inches from mental math. I just did that mentally based on our previous lesson. All right, thanks for watching today. If you missed anything, just go back and review, and have a good night.